had epilepsy that was fully diagnosed, and unfortunately because of that I was having about 7 episodes a day. The best description I actually had was if you come to the end of a train line and there's no stoppers there, if you imagine the train not being able to stop and it would just literally be going all over the place. That's what my brain was causing at the time, and that's why I was having so many episodes.
We're here today in the University of Kent kicking off a 2-day hack. The goal of this hack is to be able to help people who suffer from epilepsy to be able to manage and control their condition.
What's really exciting about this is that this is really a first-of-type project. So we're combining pretty smart wearables with patient-facing applications, and we're combining that with enterprise communication technology, which gets messages out to care teams in real time.
The University of Kent team is bringing into the project the experience we have working with wearable sensing technologies. Our main objective in the project is to build a system that can detect epileptic seizures using sensors from wearable devices.
We've split into 3 distinct work streams. The work streams will report back on a regular basis. We can then change direction as required.
Currently, it's very much that the patients are supplying this information to us, but we want to provide some insights back to them to help them manage their condition.
Putting a lot of the data into secure Azure environments, and what that does is that gives us huge scale, and it gives us the ability to easily leverage machine learning and artificial intelligence capabilities as services and ultimately improve patient outcomes.
Some of the first insights that we got that we weren't expecting were coming from the anomaly detection. Some of the insights that we got into the gyroscope data led us to thoughts about what was actually happening for patients, and has then led to a meaningful discussion between lots of the different work groups based on cross-correlation across different areas.
The next phase is for us to start engaging both the clinicians, so give them real-time information about the amount of seizures or the seizure events that are occurring for their patients, but also try to give a rapid response to the carers of those patients.
The early data suggests that we got a 30% reduction in emissions from a combination of different component parts of the solution, and that's a real benefit, both from an economic basis, but more importantly to the patients. The evidence that we have suggests that we are improving the rate at which we're responding to patients by up to 5 days. So they're getting advice about what to do much more quickly.
Although we had the epilepsy nurses on the end of the telephone, I would always wait until I had my outpatients appointment to discuss any problems that I had. I would always write my epilepsy episodes on a piece of paper. So this app has made a huge difference to me controlling my epilepsy.